Hi guys, welcome back. And this is the class 3 of stoichiometry. We have done class 1 where I talked about relative molecular mass and percentage composition. We did class 2 where I talked about empirical and molecular formula, and I solved a whole lot of questions on that. So we're moving on to class 3, and what we have been talking about so far has been composition stoichiometry. But now we want to go to where work is. So please, this is where you have to be calm and listen. So we want to talk about reaction stoichiometry. That's the second part. And this is where most students used to have issues. So get your pen ready. We'll be looking at reaction stoichiometry in this class. First is we will look at what is reaction stoichiometry. We're going to look at how to balance chemical equation, and we're going to look at mole concept and how to solve questions on reaction stoichiometry. I'm going to take each of your past questions at the end of the entire class, and I will solve all of the questions from your past questions so that you just use all this class, deal with those questions, and I'm sure you are never again going to have problems with stoichiometry. So please get your pen ready. So in case you are a first timer, listen to this. We do a lot of reactions in the laboratory. If you are a science student, you mix acid with a base to give you salt and water. Now you need to know the amount of acid that will be added to the base to give you salt and water. This is the essence of reaction stoichiometry. You can't just get to a particular salt without knowing the amount of acid to mix with a particular amount of base. Now, even if you have never done chemistry before, this is what we are trying to say. Let's say A has to react with B to give C. But now, I need 2 times of A to react with 1 time of B to give me 2 times of C. What does this mean? That means every time I want to produce C, I need 2 parts of A, 1 part of B to give me 2 parts of C. I'm doing this, let's say you don't even understand chemistry at all. So what does that mean? So that means that if I have 10 parts of A, how many parts of B do you think I will need? Very good. Since this is 2 to 1, then I will just need 5 parts of B. Then that will give me how many parts of C? Very good, 10 parts of C. This is what we do in stoichiometry. You are going to need 2 parts of A to give 1 part. So now, this is what we now do in chemistry. Imagine I want to prepare water. The equation to prepare water is H2 plus O2 to give H2O. Now, we use to balance equation. I'm going to teach you that. This is just an introduction. So now, look at what I have here. 2 parts of hydrogen require 1 part of oxygen to give 2 parts of water. Meaning that if I say I have 5 parts, I will tell you what units are and all of these things. But just for, let's assume you are even a beginner. If I have 5 parts of hydrogen, how many parts of oxygen will I need? 2.5, because the ratio is 2 to 1, abi? So I will need just 2.5 of oxygen. Then how many parts of hydrogen will I need? Then I will produce 5 parts of hydrogen. That's what this means. So what we do in reaction stoichiometry is that we determine what amount of a particular reactant will be needed by another reactant to give a particular product. So reaction stoichiometry is defined as the quantitative determination of how reactants come together to give a particular product, or the process of using a known to determine the unknown. Now in this case now, because I know this ratio, I have 5 parts of hydrogen. Can I determine the rest? Yes, that's what reaction stoichiometry does. That means I can say this part will be 2.5. Why? Because I know this. Then why this part will also be 5? Because the ratio is 2 to 1 to 2. I don't need to write 1 here since it is 1. Now, another thing is that, let me give you this. If this is 20, what do you think this will be? Absolutely 10, and this will be what? 20. So you can see that reaction stoichiometry depends on reactants and products. Anything we have on this side is called reactants, What we have on this side is called products. So when you now want to speak chemistry, you will say 2 moles of hydrogen react with, plus in chemistry means react with 1 mole of oxygen. Arrow here means to give 2 moles of water. And these are the things we are going to be needing in this aspect. So this is just the beginning. Now in reaction stoichiometry, a lot of times you hear mole to mole, mole to mass, mass to volume. Just take your time. I'm going to come back to teach you that. But I want to treat this as if you don't even know anything at all. You have no idea. So that's why I would like you to take your time in this class. The video might be a bit long, but take your time, calm down. You want to understand stoichiometry. So don't let me just jump to mole, mass to mass, mass to volume here and there. So the first thing you need to know on reaction stoichiometry is how to balance chemical equation. So this class will only be on how to balance chemical equation. The next class I will now start more concepts, and I will give you some formulas, and we'll start relating things, and we'll start solving questions. Then I will now give you shortcuts to solve those questions. For now, I'm not going to teach you those shortcuts because I need you to have understanding. Because where most students used to have problem is cramming shortcuts here and there, and they get to make mistakes a whole lot of time. So what I want to do for you now is that let's learn how to balance equation. So in chemistry, there is what we call chemical equation. So how do you define chemical equation? Chemical equation is defined as the symbolic representation of chemical reactions using chemical formulas. Always make sure you write all of these things I'm saying. Chemical equation is defined as what? Symbolic representation of chemical reactions using chemical formulas. So for example, this is a chemical equation. Sodium hydroxide can react with HCl to give me NaCl plus H2O. So this is called a base in chemistry, this is called an acid, and this is called a salt, and this is called water. I'm doing this as if you're a learner of chemistry. So now, an acid will react with a base to give me salt and water. So this is a chemical reaction. Acid is reacting with sodium hydroxide. That's a reaction to produce salt and water. So if you want to interpret this, you will now say, if you check the equation is balanced. I will teach you how to balance equation because there is 1 mole of sodium, 1 mole of sodium, 1 oxygen, 1 oxygen, 2 moles of hydrogen, 2 moles of hydrogen, and 1 mole of chlorine. So everything is balanced, 1 atom of chlorine. So now from what we have here, you can now say that, listen, you can say as a student, 1 mole of sodium hydroxide will react, plus means will react. 1 mole of sodium hydroxide will react with 1 mole of hydrogen chloride. Arrow means to give. So to give 1 mole of sodium chloride plus and 1 mole of water. Do you get that? 1 mole of sodium hydroxide will react with 1 mole of acid to give 1 mole of sodium chloride plus 1 mole of water. So that is the interpretation. So this is called the chemical equation. What I wrote the other time too. Now, how are you going to interpret this? So in this case now, I'm not putting their states not to waste time. This will be an aqueous state, this will be aqueous, this will also be aqueous, and this will be liquid. So we are going to learn how to do all of those with time. So in this case now, how do you interpret this? 2 moles of hydrogen react with 1 mole of oxygen to give 2 moles of water. That is what this means. So now, that's the first thing, chemical equation. A balanced chemical equation is important in reaction stoichiometry. What do I mean by that? 2 moles of hydrogen reacting with 1 mole of oxygen. This equation is balanced, meaning that I have 4 hydrogen here, 2 oxygen here, 4 hydrogen here, then 2 oxygen here. So that's a balanced equation. Without balancing equation, you won't know how things are supposed to react. You already know one part of a car reacts with 4 tires to give us a product of a car, provided it's a normal car, not a truck or a trailer or something. So now, let's learn how to balance equation. So they now give you an equation and they say you should balance it. So the next thing is, So now you know the definition for chemical equation. So balancing of equation is the next thing. So how do you balance equations? So take your time. I will teach you two ways. So when balancing chemical equations, there are two methods you can use. The first method is called inspection method. Inspection method. Not only the police officers carry out inspections. So as a chemistry student too, you can carry out inspection. Number two is by simultaneous method. So, or simultaneous equation. These are the two steps we use in balancing equation. The first step, inspection method, simply means inspect, look into something. That's what it means. So you are given an equation, for example, N2 plus H2 to give NH3. So you have to inspect. How many nitrogen do you have here? I have one and two atoms of, I have two atoms of nitrogen. How many do I have here? Just one. So that means I can put two here. You are inspecting, this thing is not balanced, so let me put it to balance on both sides. Then you look at hydrogen, how many? Oh, this is two. Now this is three times two, that's six. Wow, it's not balanced. So what do? We can also add three here, and that makes it balanced because this two times three makes it six, and three times two also make this six. So that means the equation is now balanced. So you can see there are two atoms of nitrogen here, six atoms of hydrogen, two atoms of nitrogen, and six atoms of hydrogen here. So now this equation is balanced. Can you balance this by inspection? I already did this the other time, but I want you to try it on your own. So all you are just going to do is look at the number of the atoms on both sides and balance it. Two hydrogen here, two hydrogen here, two oxygen here, one oxygen here. So what do? You will add two to the front of this. One of the mistakes you should not make is changing the subscript. Don't say because there are two oxygen here, then you now put two here. You are saying something else entirely. That's hydrogen peroxide, not water. So you don't change the subscript when you are balancing equation. It's permitted, you can write at the front. So now there are two hydrogen here, but there are four hydrogens here now. So you add another two here. So by inspection, you have looked into it and you have balanced it. Four hydrogen here, one oxygen here, I mean two oxygen here, two oxygen here, and four hydrogen here. So that's balanced. But there are some questions that, there are some equations that are so difficult to balance. That's when you use simultaneous methods. And I gave some of my students an equation in the class. I said they should balance, and it took them a whole lot of time. The major reason I asked them to do that was that most times they used to feel simultaneous method is actually stressful because it involves mathematics. It is not. It's something that can actually save you time. Instead of stressing your brain, you can just quickly solve it and get your answer. But now, I will do the same thing. Now, quickly, how do you use simultaneous? Let me use this simple one to first explain it so that you understand it. There are three major rules you use when you are using simultaneous method. So, right, number one, put coefficients at the front of each formula. Put coefficients at the front of each chemical formula. What does that mean? That means that you put A, B, and C. If they are more than that, you continue A, B, C, D, E, F, and so on. That's the first rule. Put coefficients at the front of the formula. Second rule, set up equation for each element. Set up equation for each element. That's second rule. Have you written that? So what does that mean? You will say for nitrogen. So you want to set up an equation now. How many nitrogen do you have here? That's 2A. Because you know if 2 is here, that will be 2 times 2, that will be 4 nitrogen. But now it is A, so you say 2A. So that will be 2A. There's no nitrogen here, so you, this arrow you now say equals to, how many nitrogen do you have here? Just C. So that will be your equation one. After nitrogen, the next element you have here is hydrogen. So you say 2B will now be equal to 3C. 3C. So that's all. There's no any other element again. That's how you do in this aspect. So now there's no So now there is no any other element again. That means you are okay. So rule number 3, assume the first letter to be unity. Let the first letter be unity. That means you now say let A equals 1. So if A is equal to 1, what do you think C will be? That will be 2 times 1. So that means C will be equal to 2. Do you get that? So you now slot whatever the value of A is into the equations. Now there is A here, 2 times 1, that will be equal to 2, and that gives us C. So C is equal to 2. So now, if C is equal to 2, what do you think B will be? So that means 2B will be equal to 3C. So that will be C is 2. So that B is going to be 3 times 2, that's going to be 6 divided by 2. So B is going to be equal to 3. So now B is equal to 3. That's all about it. Those 3 rules are the rules you use. First is put up coefficients at their front, set up equations for them, then assume the first letter, which is this letter, to be unity, and start solving simultaneously. So now that you know it, you now say since A is 1, so 1 is there, B is what? 3, so you put your 3 there. Then C is what? C is 2, then you put your 2 there. So you now check, how many nitrogen do I have here? 2. How many nitrogen here? 2. How many hydrogen here? 6. How many hydrogen here? 6. 2 times 3 is 6. 3 times 2 is 6. That's solved. So do this yourself. Let me see if you can do this. So balance this yourself. H2 plus O2 to give H2O. So balance this using simultaneous method. So now, simultaneous method is actually used whenever the reaction is so complicated. You simultaneous method will waste your time if you are using it for this simple equation. You could have looked at this and say 2 here, 2 here, 2 here, then you put 2 here, then that changes this one to be 4, then you put, and that's all. But when you have a complex equation, you use simultaneous method in balancing the equation. But before you use simultaneous method, I will give you a question. Try to balance that question using inspection method. And let's now see, that will make you to appreciate how simultaneous method works. Because you might be looking at it that simultaneous method involves mathematics here and there. So let me give you this equation. Cu plus HNO3 to give me Cu NO3 2 plus NO plus H2O. So please balance this equation using inspection method. I'll be waiting. When you are through, you can call me. I'm back. So now it's going to take you a long time to balance. That's the sincere truth. So spend your time and all. But you can, if you already understand simultaneous method, you can quickly do it very fast and get your answers. But I'm going to do it very slow so that you understand it. But the fact that I'm slow does not mean that it's not that fast. So let's do it. What's the first rule? Assign coefficient at the front of each formula. So I can have A, B, C, D, and E. So that's the first rule. What's the second rule? Set up equation for each of the elements. So you are now saying that for copper now, what's the equation? Copper here is A, so there is no copper here, then you go equal to, then copper here is C, and that's all for copper. The next element is hydrogen. So hydrogen here is just B. So you now write B is equal to, is there hydrogen here? No. There's no hydrogen here, but there are 2 hydrogen, 2 E here. So 2 E of hydrogen. So you say 2 times E. So that means that's 2 E. So you can say this is your equation 1, this is your equation 2. So you set up as many equations as possible. The next one is nitrogen. So now, how many nitrogen do you have here? Just B. This 3 is not for nitrogen, it's only for oxygen. So that means B will be equal to, do you have nitrogen here? Yes. This bracket shows that this 2 is for both oxygen and nitrogen. So you now say 2 times N. That would be 2, sorry. So you now say 2N, that would be times C now. So that would be 2C. Then nitrogen is here plus D. Is there nitrogen here? No. So this is equation 3. So let's move on. So the next one now is oxygen. So you now say how many oxygen do you have here? That's 3B. So you're going to say 3B is equal to 2 times 3, that's 6, 6C plus D plus E now. So that's equation 4. So now you are done with all the elements. There's copper, there's hydrogen, there's nitrogen, and there's oxygen. So that is the thing. So what's your rule number 3? Rule number 3 says that let the first letter, so you now say let A is equal to 1. Let your first letter be unity. So now that A is equal to 1, can you now start solving for them one after the other? So put A into equation 1, then you will get C. That means if A is equal to 1, C will be equal to 1. Now, if you look at this, there's no A, there's no C. So this looks a bit not okay. Then you can put C here. That means if B is equal to 2C plus D in equation 3, then C here can be 1. So you can now say B is equal to 2 plus D. I hope you're following. So that's another thing. Now, you want to try as much as possible to simplify all the equations so that they can have common factor. So now, what do we do? B is equal to 2E here and B is equal to 2 plus D here. So you can say B, since B is equal to 2E, then this B, you can write it as 2E, which will be equal to this 2 plus D. I hope you're following. Let's make D the subject of the formula. So you can say D is equal to 2E minus 2. So let me call this equation 5. Now, I know D, I can put it here so that I can have E here. E is common now. I know C, which is 1. I know even B to be 2E. So you can now say equation 4, from equation 4, then what do? You know B, which is 2E. You want E alone to be here. So you now say 3 into 2E, that's B, will be equal to 6 into C, which is 1, plus D. What's your D? That's 2E minus 2 plus E. So everything now is E. So you can solve for E. So you can say 6E is equal to 6 minus 2, that's 4, plus E plus 2E plus E, that will be plus 3E. 6E minus 3E, that's 3E, is equal to 4. So E is going to be 4 all over 3. So now my E is equal to 4 over 3. So I have E, I have C, I have A. Can I solve for B now? Yes, since I know E. So I can now say, since E is equal to 4 over 3, then I can say B is equal to 2E. And that will be 2 into 4 over 3. And I think B is going to give me 2 times 4. That's going to be 8 all over 3. So now B is 8 over 3. E is 4 over 3. C is 1. A is 1. I hope you're following. So now I know B. The only thing I don't know now is D. But can I solve for D from here? Yes, since I know E. So that means my D is going to be 2E minus 2, which is going to be 2 into 4 all over 3 minus 2. And that's going to be 8 over 3 minus 2. So finding my LCM, so I'm going to have 3 here 1 times 8, that's going to be 3 here 1 times 2, that's going to be 6. So that's going to be 2 all over 3. So meaning that my D is equal to 2 over 3. So I know D. So now I know A, C, B, E, and D. Now that I know them using simultaneous method, then I can slot them into this value. Now, don't get confused. All I've done is set up the 4 equation, then let the first letter be unity, then start slotting them in to solve for each of the letters. That's all I've done. So don't be confused. I have to be fast so that it's not that difficult. So now that I know my A to be 1, so I can slot those values in into the equation. So now you should write that down and practice it again. Then you try to set up equation to also practice it on your own. Just give yourself a complicated equation, then do what I've done as well to solve for it. So now your A is 1, so you just write C plus your B. What's our B? Our B is 8 over 3 HNO3 to give our C is also 1, so we just write Cu into bracket NO3. Then our D, what's our D? 2 over 3. So we now write plus 2 over 3 NO plus what's our E? Well, the AC, that's 4 over 3. So 4 over 3 H2O. So now you have your equation. But you don't leave equations in ratio like this. And since everything is over 3 over 3 over 3, in order to cancel out the 3, so you now multiply through by 3. So meaning that 8 over 3 times 3, so you say 3 times Cu, that will give you 3Cu, plus 8 over 3 times 3, 3 and 3 will go, that will be 8 HNO3, to give 3 times this, that will be 3, that will be 3Cu to NO3 and 2, plus 3 times this will be 2NO plus 4H2O. So that's the equation. So let's check if the equation is balanced. So there are 3 copper here, there are 3 copper here. There are 8 hydrogen here, 2 times 4, there are 8 hydrogen here. There's 8 nitrogen here, 2 times 3, that's 6, plus 2, that's 8 nitrogen, that's okay. 3 times 8, that's 24 for oxygen. 2 times 3, 6, 6 times 3, 18, 18 plus 2, that's 20 plus 4, that's 24. So all the atoms are balanced. Voila. So that's how to do it. So now today we have learned how to balance equation using inspection method and simultaneous method. Practice all of these things. In the next class, I'll be going to more concepts, which is where our calculation really is. So I'll teach you limiting and excess reagents and every other thing that has to do with it. And I'll give you the equations we're going to be using to solve questions. So please, if this is your first time on this channel, please subscribe so that you can encourage us to do more. And I can see the rate of increase of the subscription. So I want to say thank you to all of our subscribers. We really appreciate you. We're not going to take you for granted and we're going to serve you right. So just always leave in the comments what you want us to do for you. And we are absolutely going to help you work on it. Either it is easy or it is not easy. We're going to help you to work on it. So God bless you. I love you so much. Please do your best to practice and let's make our education better in Nigeria as well. So we are hardworking, we are strong, and we are going to get better in all the things we do. So say to yourself that I know my book, I have understanding more than my teacher, I will do great and greater things in life, and so shall it be for you in Jesus' name. So keep practicing and keep trying, and don't forget the place of God in your life. I'll see you in the next episode.